All right, so significant figures, significant digits. I guess we should start at the beginning like we did the other day. Why sig figs? Why do we care to begin with? Why is this even a thing that we have to discuss? What do you mean by that? I think I see where you're going with this. All right, so sort of, but that's more of the reason we use scientific notation than significant figures, right? So scientific notation, yes, we don't want all those extra zeros. But what about sig figs? Why is this a thing? Why do we care? Specifically in science. I don't know, maybe this is in other subjects you have significant figures too, but in science, why do we care to begin with? So if I send you, I don't know what the boss would be. I'm the boss, and we work at a nature preserve. You guys have heard this story before if you had me last year. And I'm going to send you out to count bison in a field. Hey, out in the west pasture, we got a bunch of bison. I want you to go out and count those, Gio. Let me know how many bison are out there in the field. So you run out there in your four-wheeler or your side-by-side or whatever. You go out there. He spends half a day. He's counting up bison. Comes back to the office, and he says, boss, there's 300 bison out there. Now, I know there's however many bison, give or take, right? How exact, without him saying anything other than, yeah, there's 300 bison out there, without him saying anything else, how confident am I in that count? What do you mean by that? Not very. I agree, but what do you mean?
You're going to say like it's exactly 300?
Yeah, so if he just comes back and says, yes, there's 300, do I think there might actually be 302 bison out there, maybe 294? How exact do you think he is? Just by him saying 300. Spent half a day counting up bison with I don't know, maybe use a notebook, whatever. How exact do you think that number is? In science, oftentimes, right, we want to be precise, right? That's the whole point. If he came back to me instead and he said, oh, boss, there's 302 bison out there. Now, how exact do you think I feel? Pretty exact, like that all of a sudden, just by nature of it not being a nice, even 300 number, all of a sudden 302, I feel way better about that. Now I feel like he's being exact, right? Just by nature of, it's a different number, he told me. 302 to me seems like, man, he really counted that, right? How far is it to California? I don't know. It's 3,000 kilometers, right? Now, California's a big place. Right? Some part of it probably is 3,000 kilometers away. But if I said, yeah, I'm going somewhere in California, it's 3,246 kilometers. Right? Now all of a sudden I feel better about that number. I feel like it's more exact. Just by nature of the number that you used. In science, we can't have that ambiguity. We can't be like, well, I don't know if he's sure this time and maybe another time he's not. I can't rely on the number being precise in and of itself. I need a way to signify that, right? And that's the whole point of sig figs with numbers, right? And we talked about this a little bit with like scientific notation, for example. There's a way to always be exactly precise and know how many sig figs you have in some number. So let's get into the nuts and bolts of how we actually do this. I think I did this already. Move this up. So this is what I would put in your notes. Leading and trailing zeros are not significant. Now your next question should be, what are leading and what are trailing zeros? And we're going to talk about that here directly. But for the sake of knowing sig figs, this really is all you need to know. Leading and trailing zeros are not significant. Now, the alternative way to learn this is to learn a bunch of separate rules. I would rather focus on just know this rule and you're good. Everybody else got this down? So let's see what I mean. We kind of practiced this the other day. All those zeros, what do we call those? Trailing zeros. So are they significant? No. How many sig figs in this number? 3. So trailing zeros are just zeros that follow a big number. Okay, no decimal points, no nothing else, just big number. 356, I guess that's 3,560,000,000? 3 billion? I don't know. Whatever that number is. Right? All those zeros don't count. What about this number? What about those zeros? What do we call those zeros? Leading zeros. Are those significant? No. Now this works for smaller numbers too. There doesn't have to be all those different zeros, right? This number here, for the purpose of sig figs, right? Oh, there's only one zero there, but does that zero count? No, still a trailing zero. Same thing with a little number. It doesn't have to be a bunch of zeros to make them non-significant. If they're leading or trailing, they don't count. What about this, though? What about that extra zero at the end of 0.0356? Is this a trailing zero, as we defined it a moment ago? Is that a zero at the end of a big number? No, so it counts. That's a significant digit. Right? And that's really it. Like, that's sig figs in a nutshell. If it's a leading zero or trailing zero, don't count it. If it's any other kind of zero, count it. Right? If it looks funky, now all of a sudden what happened to that top number? Why is that all of a sudden significant? Is that zero still a trailing zero? No. Once you add a decimal, now it's something else. I don't know what you call it, but it's definitely not a trailing zero. Right? If you had another zero for some reason, I don't know. Right? Now neither of these are trailing zeros. You put a decimal point in there, you botched it all up. Just look for leading or trailing zeros. They're not significant. Any other case, the zero is going to count. We didn't necessarily talk about it, but obviously, is that a leading or a trailing zero? No, it's just a zero and a number surrounded by other sig figs. Count it. Questions on sig figs? Okay, let's move on. Now, if I'm boring some of you to tears, I apologize for that. If you already know this, Climber, I don't need this, well, we're going to go through it anyway, just in case. Based on the pretest we took last week, more of you need to review this than less. So let's talk about metric conversions. We'll write a sample problem up here. .5 liters to milliliters. That's a common enough kind of conversion that you would see. liters to milliliters. So the trick here is we've got to figure out, before we even get started, kind of what kind of conversion this is going to be, right? And in this case, this is all metric, right? Milliliters to liters, centimeters to kilometers, whatever. Right? And then to start this, we all know how to start this. Draw our T-chart, copy down our units. And now finally we have to start making some decisions as what to do here next. And in metric, we always want to go to the base unit. Once we're at the base unit, then we can go to something else. So in this case, this is super easy. We started at the base unit, right? Liters or grams or meters or whatever, right? We're already there. So all we need to do is the conversion. Now you get out your yellow sheet. You guys are going to want this for today. So grab your yellow sheets from last week. Like I said, this is like a periodic table. So if you don't have one of these or you lose it, I'll lose patience eventually, but if you go through a couple of these throughout the semester, I will be over it. Anybody not have theirs today? All right, good. Good start. One day in a row. So the easy sauce here, you simply pick which of the two things you're converting is higher on this chart. Liters or milliliters? Liters is higher, it gets the 1. Next, you just count the steps between them. So to go from liters to milliliters, we count 1, 2, 3 steps. That becomes 1, 2, 3 zeros, and your conversion factor is completed. All that's left is the math. For one that is, I'm not going to say more difficult, but has more steps, 0.75 kilometers to centimeters. So again, let's right off the bat, are we all in metric here? Yes, metric to metric. Start your T-chart. Copy down your initial units. And now I'm in kilometers, so I need to go to the base unit. Copy down my units. And for meters, we can go to whatever else we need. And now we just fill in the blanks. And again, with your yellow chart. What's bigger, a kilometer or a meter? Kilometer, for sure. What's the conversion factor? How many steps? 3 steps, 3 zeros. Meters and centimeters, what's bigger? How many steps? 2 steps. The rest is just math. What do we get here? 75,000. But climber, I hear you say, I can figure out how to go right from kilometers to centimeters by just counting all the steps in between. You're right. You can do that if you'd like. It's just an extra step. But then you're going to get into maybe 7, it might be 8, it might be 12, it might be a bunch of zeros. I don't want you to confuse yourself. I always do it in an extra step, but I'm not going to necessarily mandate that. However, if you confuse yourself and you do 7 instead of 8 steps because you missed one or whatever, I'm going to have very little remorse when you're off by a decimal place. But that is all you need for metric conversions. Any questions? I know this is pretty simple stuff. So tomorrow we'll do some not metric conversions where we'll enter in the standard stuff. We'll talk a little bit about that. We'll also talk about two-dimensional conversions. That was like we did on that quiz that first day, miles per hour to meters per second. We'll talk about doing that as well. And then we'll actually get some science started later this week.